Welcome to our next adventure. This time, we're going to take a look at something that I think a lot of people will find interesting, and that's a comparison between StarNet2 and the most recent version of the StarXterminator AI, in this case AI 8. And we're going to look at this on a variety of different telescopes and image types to try and compare what are the strengths and weaknesses of each, and to see which works better in which circumstances. All right. So here we have the same image. It's M100, and it's an RGB image taken with a Ceravolo 300mm astrograph. It does have a central obstruction, and the camera is an FLI 16200 CCD. So here's what was done to the image beforehand. It was cropped. We combined the image, ran deconvolution, then ran DBE, a PCC, photometric color calibration, and then stretched using the generalized hyperbolic stretch script. And that's where we are right now, ready to do star removal before doing any other processing. Let's go ahead and run Starnet. There's our Starnet result. Here's our StarXterminator result. And in both cases, we're generating the extracted stars as a separate image. All right, here is our result. Let's get that out of the way. First, let's double check our execution times. And 52 seconds versus 50 seconds. Sometimes one's a little bit faster than the other. Actually, in both cases, this is a little bit slower than what I normally get, which is probably being caused by the recording software sucking up some CPU. Let's look at the results. Let's bring that over. And that. Now we can see this is the StarXterminator result. There's a star halo. That's probably a star halo, and that's a star halo left behind. And those things are not showing up on Starnet, so that's kind of a win for Starnet. Let's take a look at what else is going on. We've got stuff here, and I think down here, that are showing up on StarXterminator that are not showing up on Starnet. Let's take a little closer look. That one, at least, is a galaxy. Let's match up our views. And Starnet just wiped that galaxy out of existence. But yeah, this is definitely star halo gunk up there. So at first glance, Starnet does a cleaner job, but it also removes some stuff that it shouldn't. Yeah, there's another galaxy right there that Starnet removed. Let's take a look at the stars. So this is the Starnet version. Oh yeah, and that galaxy that Starnet removed actually ended up in the star mask, so all is not lost. It didn't destroy the information in this case, it just put it in the wrong spot. And let's zoom in there. This is the Starnet version. Our galaxy that was in the starless version correctly isn't here, which is also correct. But look what it did to that star. In this case, the star mask from Starnet is definitely cleaner. Let's bring that down there and take a look. actually line things up. So yeah, in general, Starnet seems to do a cleaner job of removing the stars and their artifacts, but it also was removing a few things that it shouldn't. Which one do you prefer? In my case, I think the Starnet version would be easier to work with, but it's possible that it could end up, in this case, it's fairly easy to tell that the things that it removed from the starless image that it shouldn't ended up in the stars. But maybe there are cases where that doesn't happen. So I'd say neither is perfect, and you have to choose which set of artifacts is more easy for you to work with. All right, let's switch to another image from this telescope, but this time a narrowband image where we're doing star removal while things are still mono. And let's see what happens. All right, here's our next example, which is a Sharpless 173, otherwise known as the Phantom of the Opera. This is a hydrogen alpha image. It's from the same Ceravolo astrograph along with the FLI ML 16200 camera. But in this case, it's just a mono image. Now, this data was cropped. It had deconvolution run. I don't think I ran DBE. Let's take a look. No, just histogram transformation. So, very minimally processed to this point. This is data from late last year. Okay, we have our first one done. And for StarXterminator. All right, we have our results. On the surface, both look pretty good. And 50.5 versus 53. This time Starnet was a little bit faster. In both cases, this is about 4 to 7 seconds slower than it normally is. I think it's probably OBS Studio. Both of these look pretty good. Let's take a look at our preview here, side by side. I don't see a whole lot of difference. There's a little bit right there. Let's put these on top of each other so we can blink them. Okay, so StarXterminator leaves that star halo blob behind. And Starnet2 does a slightly better job with it. It's still a little bit there, but it's cleaner, at least to my eye. Let's come down to a spot where we've got a lot of detail, at least for this nebula. Yeah, we've got that same blob there. Other than that, they look very similar to me. There's another little blob here on Starnet. Where'd it go? Hold on. There it is, right there. Both seem to struggle a little bit there, but it's not a huge difference. Probably wouldn't be that noticeable once you added the stars back in. So let's take a look at those stars. They look very similar, at least there. Let's going up here to this big bright star that left a blob in both cases. So here, both seem to do a really good job. Very few artifacts. I think both would be easy to work with. I might give a slight edge to Starnet, but it's only a slight edge. I think I could easily work with both of those. So now let's move to another telescope and see what we get. Now we've switched to a Planewave CDK14 with an FLI ProLine 16803 sensor. This is an LRGB image with a very dense star field. Let's see how both do. First, Starnet. All right. And StarXterminator. All right, here we go. Let's do our comparison. Well, we know that this image had some very clipped stars in it. And in both cases, we can see the artifacts remaining. It looks like StarXterminator actually left a star in there. This is a brutal image for either to deal with. Let's blink them. So both leaves artifacts in about the same spots. It's just a question of degree. If we zoom in there and there, we can see Starnet leaves a blob there for what was behind the star. Well, not behind, but the halo surrounding the star. And Starnet does, StarXterminator does that. That is not pretty. But yet both handled the star that was here. Well, no, actually, StarXterminator did a bit of a worse job. Let's take a look at this one. Neither is pretty. Let's take a look at the stars. Now, to be fair to both processes, this image had a lot of bright clipped stars in it. This is kind of a worst case torture test. All right. Wow. So clearly they both have issues. Here's the case where StarXterminator left the star, but extracted the diffraction spikes. And StarXterminator extracted the spikes and the stars. This little artifact, not sure where that came from. But if we look at this, It's not actually clipped. It might have been in the original, though. About the same. So here I think neither gets an A. I think I'd rather work with the Starnet version than the StarXterminator version, but frankly, both are going to be somewhat problematic. Let's take a look at a narrowband image from this telescope. All right, here's our narrowband example from the Planewave 14. This is the Tulip Nebula H alpha, and let's see how they do. And StarXterminator. Let's see how we did. At first glance, they both look pretty good. Let's get that cursor out of the way. As I blink back and forth, I can't see a difference. Let's zoom in and zoom in. They look very, very similar. Let's come down here to where there's more detail. I think both of them did an outstanding job here. Let's take a look at the stars. Let's get you back in the screen. No, I don't see a difference. Let's come down here to where there's a brighter couple of stars. I think on this image it's a draw. Now let's go to something different. We've had big telescopes with central obstructions and CCDs. Now let's come to something that maybe is a bit more common, which is a refractor with a CMOS camera. All right, we're now going to do an RGB image. This time it's Bernard 352. And this is on a Takahashi TOA 130 with a QHY 268M camera. So this is RG and B monofilters which have been combined and stretched. All right. Let's take a look. Let's get rid of these previews. All right, we do have some differences. The most obvious one is right there. But you can see StarXterminator tends to leave more blobs than Starnet. Let's zoom in here. Let's take another step in. All right, so now they're both in at 2 to 1. You can see StarXterminator leaves a lot of little star circles behind that Starnet doesn't. It leaves some, but not as many. I think we have to say that neither is perfect, but let's come down here. So we've got this kind of difference going on here. I don't know which is right and which is wrong here. We're going to back up and look at the raw images, or the pre-star removed images, and get a little bit better comparison there in a bit. But let's take a look at our stars. And this is another case of a torture test. It's a very, very dense star field. And at least on this section, both look to have done a very good job. Let's come up here. Take a look over here. So yeah, the stars in both look pretty good. I think either one would be easy to work with. Oops, let's get these guys out of the way. And go back, take a look at this. So here we've kind of got this going on here. I think that's artifact from leftover from StarXterminator, but I'm not sure. Let's see if we can back up there. And if we back up, it's just impossible to say. What we can say is there's this line of stars going up here. And I think, come on, I think that's a strong argument that these are artifacts left in by StarXterminator. So if we go there, yeah, I think so. So I think I have to give the win to Starnet on this image, although it's not a huge difference. However, let's go take a look. We have on the same image an H-alpha version. So let's get rid of those stars. And here is the H-alpha version of the image. Let's get rid of the previews. That's H Starnet. And this will be H StarXterminator. So let's go ahead and run Starnet. All right. There is Starnet. All right. And at first glance, both look pretty good. Let's come in here and zoom into both. And I think they both look good. Let's come up here. Zoom in. There are small differences. There's one right there. But I don't think that difference is so big as it would cause any problem processing issues. Let's come down here. To where we've got less signal. And that looks like a blob. Okay, so there Starnet leaves a little bit of a blob. And StarXterminator seems to do the better job in this case. Although I suspect that either would be fairly straightforward to process. Let's take a quick peek at the stars. At first glance, nothing obvious appears. They look virtually identical. Let's come up here to a corner. And again, they both look really good. I think in this image, I'd give a slight edge to StarXterminator, but it is slight. I think both would do a great job. All right, so what's the takeaway from all of this? I think on broadband images, Starnet seems to do a better job than StarXterminator, although on data without central obstructions and without clipped stars, both do a great job. So I think the cleaner your data, the better you are with either tool. If you can avoid clipping your stars, then both are going to do as good a job as they possibly can. On narrowband data, they both seem to do an excellent job. Sometimes one does better, sometimes the other, but they're both pretty close. I think I'd give a slight edge to Starnet, but in most cases, but not in every case. So there you have it, at least on 6 types of images with, or 2 types of images with 3 different telescopes. I think Starnet gets the slight win, but I think both do a pretty good job. I think on telescopes with central obstructions, Starnet2 definitely does a better job than StarXterminator 1.2 with AI8. The great thing is both of these tools will probably improve over time. So Starnet2 is, of course, a free program, whereas StarXterminator is a pay program. I did buy my copy of StarXterminator, and I've been using it, was using it pretty much all the time until Starnet2 came out and won me over. What other things can I say about this? In terms of running speed on my system, on this iMac, which is an Intel Xeon-based iMac Pro, they both run pretty much the same. In terms of updating, StarXterminator has a clear win there. It's built into the PixInsight repository process, and so doing updates is quite easy. Starnet is a manual install. Hopefully it will be integrated into PixInsight like the original Starnet was, but for the moment that's not the case, and you have to install it manually, and that's a little bit of a pain. But it's not hard, it's just a little tedious. And if there is a Starnet update, then you have to do it all again manually. Whereas if there's a StarXterminator update, PixInsight tells you, it downloads the update, applies it, and you're ready to go. But I think especially for broadband images where you might have more clipped stars, especially on telescopes with central obstructions, I think that pain is worthwhile for the benefits that Starnet2 brings. So that's it for this adventure. I hope you enjoyed this comparison, and I'd be curious to know your thoughts on which of these works better for you and in what circumstances. So let us know in the comments, and until next time, clear skies.